So on Monday, we learned how to analyze the primitive operation. If you still remember the primitive operations, it means this thing, evaluating an expression, assigning a value, indexing into an array, calling a method, returning from a method, and so on. So in the primitive operations, in this example, we can see, for example, this one. This is primitive operation, or we call this is one operation. This is another operation, one operation. This is another operation, one operation, another operation, one, one. Then it means in order to run this code, we need to have 6 operations. So the best case is 6, the worst case, there are 6 operations. So this algorithm is approximately, approximately 2. So it's about 1, because every line is 1, 1, 1, 1, 1, 1. So we call this is constant. What about this? So in this case, we have 1 operation. In this case, we have n operation. So why this n? It depends on the number. If the number is 5, then n equals to 5. If the number is 10, then it means n equals to 10. If you do 5 times, then there will be 5 operations. If you do until 10, then there will be 10 operations. So that's what we call as n operation. If you look at this one, we have 2n, because there are 2 operations. The first is equal sign. This is one operation. This is another operation. So this is 1. This is another 1. So there are 2 operations. And these 2 operations will happen for n time. So this operation will happen for n times, and this operation also will happen for n times. Then there will be n plus n, or we call it 2n. This one just print, so it is only one operation. Then we can see we have 1 plus n plus 2n plus 1. What happened? If we calculate this one, we will get 3n plus 2. So the best case is 3n plus 2, the worst case is 3n plus 2. The algorithm is in approximately linear n. Okay. Now let's see another example. What about this? We have a list. We have the data 1, 3, 5, 7, 9. And then we have A will be assigned as L1. This is L1. Index 0. L1 index 0 means this is the data. So it means there's one operation. This is another operation. This is 1, 1, 1, and 1. So because this is one operation, this is 2 operations, because we have one assignment, and the other one is we want to check the data at the index 0. So there are two operations. This is also the same. We have one operation and we have another operation. So there are two operations. When we do this one, if we calculate 1 plus 2 plus 2 plus 1 plus 1 plus 1, then there will be 8 operations. The best is 8 operation and the worst case is 8 operation. So it approximately is constant because we have only 1 or 2, 1, 1, 2, 1, 2. So yeah, the operation will be about 1 something. We can say this is just constant. What about this? If we have this data A 1, 3, 5, 7, 9, and then this is one operation. This is a loop. We want to check the data in the variable A. So A, we know there are 5 data. So 5 data means it depends on this list. If there are 5, then we will go until 5 operation. If there are 10 data, then we will go until 10 operations. If there are 20 data, then it will go until 20 operations. So we say this is n operation. There will be n operation depending on the data. If it is 5, then we have 5 operations. And we will do again this one, multiply and equality. Okay? Equal and multiply. Then there will be 2 operations. Because there are 2 operations, n for this one and n for this one, then it becomes 2n. So if you calculate this one, then it will be 3n plus 3. So the worst case will be 3n plus 2. Basically, it is linear because we have n. Now, let's do something more complex. Suppose we have data in a list such that A is this one, 1, 2, 7, 5, 4, 8, 3, 6. And we want to find the maximum value on the elements. So we know that the maximum is 8. So there is an algorithm, there is a function, we call it find maximum. And we have one argument. The argument is A. A is the data. So what is the algorithm analysis? So this is the code. Then you need to understand the code. Find max, we have one argument data, and then figures. It is a variable. We have equal and data at the position index 0. So we set the first element as the figures. And then we want to do the loop. For the loop, if the value, if this value is higher than figures, so we will do the new assignment. Figures will equal to at the end, we will return the figures. Now, let's check. We will inspect the pseudocode because this is pseudocode because maybe this is just a Python code. It is easy to understand. So we can determine the maximum number of operations executed by an algorithm as a function of the input size. So the input size means any data. So let's say we have the data with n, and we can say later the number of data equals to n. So we will do one by one. We know that the line 1 is calling a method. So yeah, actually this can be different for every of us, because we may have some idea. Okay, this is one operation because we define the maximum function, and then this is another operation because we put the data. So we just say this is operation, okay, just for simplicity. And then this is comment. Comment, nothing happened in the program. And then line 3, we assign value to a variable. Assign a value to variable, and then there is also indexing. So there are two operations. Line 4, we are doing loop. Okay. So we are doing the loop here. So the loop here is based on the data. Okay. So in the data, we have an array, and the data is what you see before. This one. It is finished. Then in the previous example, I give the array with only n operation. But let's say if we have this kind of loop, so this will be a loop from 0 until the number of data, which is n. And there is also another kind of operation we call the indexing. For example, the data in the position 0. The data in the position of value. And this is one operation, and this is also another operation. So when you know this kind of syntax, it means we will see the file equals to the data in index 0 at the first time. In this case, it is the same with this, right? So we have two operations. And then we go to the next. The next means file equals to the data in index 1. And this is also another operation. So there are two operations, equal and assignment. Then there will be two operations. And it will go until n times. Then we can say this is to n operation. Line 5, it is the evaluation. The evaluation, it will be repeated until n times. It will be repeated until n times because we will do the repetition. Line 6, it will be repeated until n if the condition is true. Let's say if this one is true, then this will be executed. If this condition is not true, then this will not be executed. Then I can say the best case is 0, nothing. Or the worst case is n. The last one is written, so it is just one. We can see something like this one. So n, two operation, two operation, two n operation, two n operation, 0 until n operation, and one operation. And if this one is 0, okay, this one is 0, then you can have 2 plus 2 plus 2n plus 2n plus 1. It means 4n plus 1. If the worst case, it means this is 2, 2, 2n, 2n, and 1. So 2 plus 2 plus 2n plus 2n plus n plus 1. Then we have 5n plus 5. And the estimation of the running time will be 5n plus 5. It is the worst case. And 1n plus 5, it is the best case. So let's say I have another kind of definition, A and B. So A is the time taken by the fastest primitive operation, and B is the time taken by the slowest primitive operation. So Tn, let's say the Tn is the worst case of the algorithm find max, and the Tn will be in between 4n plus 5 and 5n plus 5. So our algorithm will run in between this one. So the running time will be Tn. This is bounded by two linear functions. Why linear function? Linear function, it means we have n and n. This Tn means the growth rate. The growth rate means when the number of n different or when there is a changing on the hardware. So if you use laptop, there will be different competition with desktop. If you use a good computer, it will be different with the just small computer. Or also the software. If you use Python, it may have different with Java. So affects Tn by a constant factor. So Tn can be affected, but you know that we have 5n plus 5, which is bounding the Tn by the same linear function. So the constant here, the constant of A and B, yeah, just a value because they are in the same function. And it does not alter the growth rate of Tn. Even though this is linear, then this is also linear. So it does not affect the growth rate. So the linear growth rate of the running time Tn is an intrinsic property of algorithm find max. Because this is linear, so we can say this is also linear. We need to check the growth rate because when we have number of data which is small, it's okay. But when the number of data is very huge, for example, I want to find the maximum salary from a list. So this data is 1275486. We have only 8 data. Now let's suppose the same data is a list of salary from the population in Seoul. In Seoul, there are 8 million people who have a job. Let's say, for example. Then you will have data for 8 million. So if you have your algorithm, how can we calculate the growth rate? And let's check. You already know the algorithm. This is logarithm, logarithmic function. This is linear function. This is n log n function. This is quadratic function. Okay, so you can check from the function that we got in the first lecture. There are 7 functions. This is cubic function. This is exponential function. Now, if you look at this one, when we have our data is 8, then n, which is 8, we can check approximately log n, log 8. You know log 8? I give you the usually we call it log, this one. This is log base 2. Lg means the log. Okay. Log base 2. So this is log base 2. Log base 2 of 8, it will be equal to 3. Just remember, this is the basic mathematics. Okay. So log 2 of x, and what does it mean? We want to see 2 power of something equals to x. Okay. So it means I want to know log 2 of 8, it means 3. And 2 power of 3, it is equal to 8. Okay. This is also the same. 2 power of 6 equals to 64. So we want to get this exponent number. We want to get this exponent number. It means if your data is big, if your data is 8 data, then you will have like 3 operations. If your data is 64, your computation time will be about 6 operations. So if you have 8 million data, then you will have not that high operation. Okay. So this is the best. What about if we have linear? Linear means n. So if you have data, then there will be 8 operations. If you have 8 million data, then there will be linear operations. If you have n log n, you can just multiply n multiply by log n. In this case, 8 multiplied by 3. So that will be about 24 operations. This is with the data 2. With the data 2, we have 8 million multiplied by log 8 million. And so on. So you can see that when the number of data is high, of course, the competition is high. And the computational, the growth rate, it is naturally based on the function. So the growth rate matters, and we just need to know the function. We don't need to know this detail. So if you have like algorithms to solve at the end of the semester, you need to show like this one. So it's if you have the insertion sort and merge sort, for example, you need to show this graph. The complexity is n power of 2 divided by 4 for the insertion sort. For the merge sort, it is 2n log n. Then when you do the experiment, when we have 1 million data, for the insertion sort, it will take 70 hours to solve the problem. When you use the merge sort with this function, it takes 47. So which algorithm will you choose? Of course, this one, the better one. You want to get the faster result instead of this one, 70 hours. So you can plot This one. If the data is high, then there will be a higher operation time. And you can see, okay, the color seems better. The blue color seems very complicated, or it is complex when the number of data is high. So the growth rate is not affected by the constant factor. If we have the linear function like this, we can also see this linear function. So what is the constant? Let's say we have 2n plus 5. What is the constant function? This is the constant, and this is constant. So 5, actually, it doesn't affect too much. When you have n equals to 8 million, what happens? 2 multiplied by 8 million, it means 16 million plus 5. Nothing. It's very small. Okay. So usually, it is, we call it, it is not factored because this number is very small. And we also say that the lower order will not affect it. What does it mean by lower order? So let's say this one. 100 n plus 100,000. Okay, 10 power of 1. So this is, of course, big. This is also big, but we still say this is just linear function. And this will affect more than the constant. The second example, 10,000 multiplied by n power of 2 plus 10 power of 8 n. So this is a constant, and this is, we call it lower order. Why lower order? We have n. The higher order is n power of 2. The higher order is n power of 3. The higher order is n power of 4. Higher order is 2 power of n. So it is getting high, and this getting low. So lower order means lower than this function. So if I have quadratic and linear, so this is the lower order. This lower order will not affect too much. That's it. If I have n power of 3 plus n power of 2, we can say this is lower order. It will not affect too much. This will affect more than the lower order. This for the n function, the complexity for time, and we also have the space complexity. Space complexity means we will estimate the memory requirement for the execution. So how many space that you need to save your data? So the criteria is the space of the input. So if you have this, let's say I have 5 data, 1, 2, 3, 4, 5, then it means the space will be n. The required space for the intermediate process. So how much space you need to do the algorithm. And the temporary data in the data structures. And the required space of the output. So we usually determine this on this one. And if we have this algorithm, what happens? Square number with empty array. So we will do the square number dot append number multiplied by number. Then we will return the square numbers after the loop finishes. So in this case, what is the space complexity? If we know that the data we have 1, 2, 3, 4, so I can assume that this data also will give the output n times. This is number multiplied by number, and this is the number. Okay. So the result will be 4, 9, 25, and 64. So there will be n according to the data. The output is this one. Then it means it requires memory allocation for the number of items in the input list. Say the number of elements in the input is n, then the space requires increase with the input size. So the space complexity is n because we have this is n. Different problem, we have different complexity. When we do with the algorithm analysis, we need to understand big O notation. So big O notation, we have function n and gn. So this is based on the theoretical mathematics. So we call this big O notation. There is a function fn and gn. We say that fn is O. O means the big O of gn if there are positive constants c and n0. So we have the constant c and 0 such that fn is less than or equal to c multiplied by gn. And for all n will be higher or equal to n0. Now let's see. I have a function 2n plus 10. It is on. Now, then we call this is the fn, and we call this is the gn. In this case, you need to prove. You need to prove by 2n plus 10, which is the fn, it will be lower or equal than c. C is any constant multiplied by gn. Gn is the on. So just multiply with n. Then by using some mathematical approach, I think I will not explain this one. I assume that you already learned the mathematics. So this from this equation, we can derive to this one. So that will be less than Cn minus 2n. And then we have, you can just make the opposite one. So 10, it will be C minus 2 and it's the same like this one. And if you want to get the n, then n, it will be higher than or equal to 10 divided by C minus 2. So in order to know any numbers that is bigger, any of this number that is smaller or equal to n, then we need to put the C at least 3. If c equals to 3, then 10 divided by 3 minus 2. So it means we have 10. So 10, it is any number n0 in order to get the result that this is correct. So C is 3 and n0 is 10 in order to check that this function is suitable. We can say that 2n plus 0 is ON. 2n plus 0 is ON. And another example, n power of 2 is not ON. You can do the same. N power of 2 is the Fn and On is the Gn. And you can do n power of 2 less than C constant of n. Okay. Then C multiplied by n. And if we do the derivation, it will be n less than equal to C. So in this case, the above inequality cannot be satisfied since C must be a constant. In this case, n power of 2 is not ON. Then what about this example? 7n minus 3n power of 3 plus 20n minus 2 plus 5. 3n plus 5. So what is the function? 7n minus 2 is ON. So I will skip the detail this one. You can check. You can do the derivation. Say 7n minus 2, then it will be Cn. Then you can do the derivation. Here we have C equals to 7 and N equals to 1. For the second one, we have 3n power of 3, 20n power of 2 plus 5. It is ON power of 3. So you can do the derivation. And we can find C equals to 4 and N0 equals 21. For the last one, we have 3 log n plus 5. So it is O log n. And we can get this derivation with the C equals to 8 and N0 equals to 2. So what does it mean? We have the rules. Big O rules. We got it? Big O rules. So if Fn is a polynomial degree of t, polynomial degree of t. So n power of t. Okay, so this is what we call as the polynomial degree of t. D, it can be any number from 1 until any number, which is integer number. So if Fn is a polynomial degree of t, then Fn is O n power of t. That is not the lower order terms. Okay, so this is what we learned before. You know what is lower order? This is the lowest. This is higher. This is higher. Higher. Maybe this is the highest. So this is higher and this is lower. If your function is n power of 3 plus 10 n power of 2 plus n, then What is the highest one? Highest, yes, this one. This is the highest, and this is the lowest. Okay. And this is also the lower. We can say drop the lower or the top. So we can drop this one, and we can also drop this one. It means this function will be n power of 2 based on the big O rules. The other is constant. So as I mentioned before, if you have 3n, 2n power of 2 plus 3n plus 500. So this is constant. This is also constant. This is also constant. So in this case, I will just apply with the big O rules, O n power of 2, because we will drop also the lower order. So use the smallest possible class of function. 2n is On. Not 2n is On power of 2. Okay, so this is not correct. Use the simplest expression of the class. 3n plus 5 is On. So 3n plus 5 is not O3n. So there is no O3n. So the function will be only the simple function. Okay, let me stop here. Let's have a break. I will continue after the break.